All right. So the prompt patterns is actually a very new topic because only related with prompts, which is also based on the generative AI. Because the generative AI only came here for 3 years, so there's not much old historical study about prompt patterns. But then this is the patterns is not a brand new concept. Okay, so especially in computer science and software engineering field, we actually also learn software design patterns, code design patterns. I don't know how many of you took the course on object-oriented design and programming. In that course, we actually talk a lot about design patterns. Okay, so well, the prompt pattern is new. The pattern concept, the approach, or methodology is not really quite new. Let me give you some kind of background. So remember in the early days, we already discussed, okay, so the large language model, basically, they're just trying to do one thing. They're trying to do this one thing really well, which is predicting the most likely next word or sequence of words based on a given context, or based on a given sentence or strings, right? So they're constantly making the next prediction just for that one token, one word, and then they attach it back and keep doing this kind of a prediction. Okay, so we'll give you these examples before that, just looking at the blanks, pretty much you can tell what the output is. And I would say that most of us, when we look at those blanks, we would not have much confusion. We'll probably have very same answer for all these blanks. Okay, just because we all learn the same thing, we have seen this happening again and again. All right. And then to summarize, so large language model is basically a machine learning model. We've been talking about some of the technical foundation about machine learning model over the past weeks. And you give the input and it just produce the next word. We showed you different solutions of using the very simple, naive machine learning model. We also showed briefly, very briefly, using some of the deep learning models like RNN, or we didn't show you the code about the transformers, but hopefully you have some ideas because the transformers are mostly on how you train the whole thing. But yeah, the model produced that output, right? And then, as I mentioned before, so each time it just produces one word only. You attach that one back, and that's how you see the whole complete results. And obviously, they did so much optimization. The whole process actually is pretty fast. You can't really feel it's actually coming one word after another. But in the early days, when the ChatGPT just came out, if you remember, I think the speed is almost like a text typing kind of an animation. But I explained that the animation wasn't there to animate. It's because how the large language model works, right? So from all those examples, what you need to understand is that as you use generative AI, okay, once the model is trained, everything you're getting, okay, is 100% purely based on that prompt. Okay, it's really what the prompt you are providing that determines the results. Okay, so for example, right here, we'll give you some other examples. So if we show all the three of these things, okay, into the ChatGPT, okay, we're gonna see totally different answers as you will expect, right? So we'll do a Mary had a little, and we'll put it in the ChatGPT, and then they will probably give us, let's see what they provide. Okay, so and they obviously they know a lot more, but then they kind of give us this complete lyrics, right? So that's what this prompt will give us. But then if I say that complete the story about a girl named Mary who had a lamb, and then they will just give you the whole version and provide the whole story because that's what I was asking. And they just don't want to not only just talking about the word, right? And then if we talk about, okay, complete story about a girl named Mary who had a G-force 390, okay? And they will give you obviously totally different things. Okay, after school, like put it outside, but also like building computers. One summer, it saved months for tutoring, do a lot of work, and finally bought the most powerful graphics card for her dream. Okay, and blah blah blah. Right. So this is pretty straightforward. But as a CS major, you want to understand the reason you see different results because you gave different prompt, you gave different command. It's like our programming, right? So you give different kind of programs, different sequence of a command, you're gonna get different results. Okay, So that actually tells us that if you want to get really good results as you use AI, you must be the master of prompts. You need to write really good prompts. Just like if you want to get a really good software, you have to write really good code. Okay. Otherwise, you're not gonna get a very nice UI, a very good functionality, no bug. The quality is all depends on the input code. And in this case, the quality of your responses is all depends on the prompts. That's why when we talk about the prompt patterns, okay, we're trying to show you how you could utilize some of the patterns or templates that has been proven to work. And someone else summarized it before for us so that we can just directly take it and use it. And you will find that learning prompt patterns is a very effective way for you to quickly master certain things. Okay, so basically the prompt pattern means some of the templates, some of the message templates or text template that you can use to solve specific problems. Okay, so before we talk too much about the prompts, I want to switch back a little bit about this slides about the design patterns. By the way, how many of you have took the object-oriented design and program course with me? The 3560. I think there was one time offer in the summer. It was a recorded version. Anyone? No? Yeah, it's a very good course. I think it's a core course right now. It talks about how you write a good code. Okay, how do you make your code very extensible, flexible. But the most important topic in that course is something called design patterns. Okay, so I'll give a very quick introduction on this one that will help you to understand the prompt pattern and how these things are related. In fact, the people who work on behind the prompt pattern are similar folks who also worked on the design patterns. Okay, so the most famous professor here is Dr. Schmidt. He was a professor at Vanderbilt University Computer Science Department. Now he become the dean of, I think, William and Mary. And he early days did a lot of work on the software patterns, software architecture pattern. He wrote a lot of good books and a lot of good papers. He's a pretty famous guy in the field of software engineering. So I actually borrow a lot of content from his slides. Okay, as we're talking about design patterns, we're trying to introduce why do we even need this? Well, the goal here is that we want everyone to become a master of software designer, software developer. Okay, we're talking about really good ones, the pros. Okay, not just the amateurs. So in fact, if you think about master, right? So for code, I probably won't call most of you as a master because you guys are still in school. I actually generally think you need some time to train in the workspace, write enough amount of code in order to become master. I do know some of you are definitely pretty good. Okay. But then you need to know that as you, as we talk about any kind of professions, the masters do things quite differently from beginners. Okay, whether it's athletes, arts or anything. Just think about the things that you know more, you know the field a little bit better, and as let's say sports, there might be a chance that you actually play certain sport with some of the professional, not necessarily professional, but some guys from like a schools team, clubs, the levels higher. You probably can feel the differences. Okay, so the goal here is the same thing as we use write code to build software. Can you become that master? Okay. One thing here you really want to remember is that as in when you see master, you don't want to always be like amazed by how the master do things can do things greatly, right? You very often we tend to forget about how much efforts they put. And that's why I was asking that, I was saying that when we were talking about, coding masters, I mean, most of you probably are not qualified yet just because you guys are too young. You probably haven't wrote that much, number of line of code. Okay, so it would take some time to get trained. Okay, a lot of masters, professionals, they just put tons of efforts behind it. So same thing for coding and same thing for AI and prompts. A very important part to become a master is to practice, put more time, write more code, more lines of code, and to repeat repetitions. That was the talk. This guy, he is actually a soccer coach, and he was talking about the importance of self-confidence in a sport such as soccer. If you ever play some of these competitive games like soccer or basketball or those, you actually know how important the confidence is. A lot of the time, you might be doing things very well without too much pressure, but in the real game, in the real competition, that sometimes cannot help you to support that kind of toughness of the real competitive games. So being confident in many cases is the key to make sure that you can still perform decently at that kind of level. But then the confident most people are not born with confidence. Okay, you're never going to expect that you will be always confident in any kind of time. That's not going to happen. And also, if you feel that way, that's not good. You just don't know how good you are, right? So, the coach said that the confidence comes from practice, comes from repetitions. And he gave me examples that, you're a goalkeeper, right? So you press a goal, like you're a goalie, and all you need to do is every day just kick the ball to the wall and then catch the ball for thousands of times. If you do that every single day, and you will actually build confidence. So there is no shortcut, right? So back to the previous slides, a lot of professionals and masters, and then it does take a lot of work. Okay, so this is really important as we're talking about coding the AI, and that's why I was asking in the early days. Well, everyone knows about AI. Everyone knows that AI is popular, it's trending, right? So it's the future. You need to learn it. But most of you have not even used some of the tools, like I mentioned, Cursor, Cloud Code, or those. Okay, that's a difference. Well, some of you, actually, small number of you actually have already tried that. So that's kind of the kind of hard work you put behind it. Okay. So in the process of becoming a master, obviously, besides the training, repetition, and practice, you also need to learn. A lot of times, the masters can give you some good help, or the coaches, the teachers, because they sometimes are able to give you and communicate something really simple, but in a very efficient way. If you somehow can pick it up, you can start apply it. That actually saves you a lot of time. Okay, so learning that from the master is definitely useful. All right. Um, so here, as we talk about the coding master, the design master, some of the misunderstanding you need to know is that if you just know the programming language very well, that's not going to be enough. Okay, so let's talk about AI here. It's same thing. You know English. Okay, you can write things. You can write prompt, but that doesn't mean you can write good prompt. Okay, knowing Java doesn't mean that you can write the most efficient program. It doesn't mean that you can produce the best, design structure that is very extensible. The other day I was explaining, I don't know if it's this class or the other class, if you want to become like a really expert on Java, you also need to master the concurrent programming using thread, multi-threading. Okay, I think that's the other course, which is a very hard subject. So just knowing language itself is not enough. You need to know all the design principles, the best practices behind it. Here is a very good example that there was a competition. I think the competition is still going on. Okay, the competition is called Obfuscated C code contest. So you basically need to write very short amount of time or even a one-liner. Okay, to produce something that's very impressive. Okay, now here is the winner. This line of code is a winner from the 2006 obfuscated C code contest. I'll give you 10 seconds to just make a guess what this program will do. This is the C code. Obviously, you have a main method here. It does something. There's some semicolons, and make a guess what the output of the program is. Anyone? Any ideas? Just guess. So I don't know if you noticed there's something called time, right? So this program is something about printing a time. Okay, so if you run the code, it actually prints out the time when the code was compiled. And then it actually print out the time in this kind of format. It's not a simple number to show up. It has to print out the time in this kind of format. It's very difficult to understand how this program even works. Okay, but it's a very sophisticated code. However, we do call this a very good design. Obviously not, because it's very difficult to understand. Very difficult to if all the programmer actually write this kind of code, that's going to be very hard to maintain, right? So we're just talking about being a master of a language, or if you know the language very well, it doesn't necessarily make you a master of a software developer. And the same thing for the prompt. Okay, you know English doesn't mean that you can write the best prompts. Okay. Other methods that we teach design, for example, we draw a lot of these graphs, software design, okay, UML diagrams, models for you to understand the architecture. But these are useful. But again, just looking at these graphs and design, you still don't know exactly. There's no guarantee you can write exactly the same quality of a code. All right. It's almost the same as like architecture, right? So if you know how to draw the design, it doesn't mean that you can build a house in that way, right? So that there is still a gap. Okay, so the bottom line here is that we want to become the master on software design, and that really depends on a lot of good experiences, a lot of good best practice. It's a very practical subject. It's not something you just know the language, design, and then you can get it, right? So in general, some of the good ways that you can learn software design, okay, the best way would be to learn those from some of this good system, the good code, right? Because a lot of time, if the software is built in a very good way, from the software, you can actually find a lot of good things on how they handle the abstraction, how they handle the reusability, how do they make sure the things are modules, can be easily extended, right? So if you look at how they build the software, then you can learn it. Just like, you want to learn building a house or decoration, you go to some of the model houses, model rooms, the award-winning houses, and then you learn from them, then you can actually see those, right? So from there, you can definitely see a lot of things. However, this is not a best way for us to learn because most of the time the knowledge is in the designers, in the software architects, right? So you can see one piece of software, but you cannot see all of them. So it really depends on the experts. Or if you say, well, I don't need an expert, just give me the code, I'll read the code. That could work, but theoretically, there's just too much code for you to understand. Still very difficult for you to learn it. So either way, this is not very good. If you don't have an expert, you don't have the knowledge, or if you have the code, it's just hard to get all this knowledge, right? So we need a better way to teach people all this knowledge, design the software, design a good software without expert, without too much reading on the source code, right? Because that's how the patterns come in. So what we really need here is kind of a way to extract, document, convene, apply, and preserve the design knowledge, without the too much time and efforts and risks. Okay, so that's the whole motivation of how people create design patterns. So, the example here is that we need to design a solution that can always be taken and used to solve a certain problem. And within the context, the problem is not a one-time problem. It's very often a repeated problem, a problem that a lot of people will see and have, so that we can summarize the really working solutions and let people to use that solution to solve that problem. All right. So here are some examples. I'll start from here. So maybe I'll talk about the trading one. So a lot of the finance company, they do a lot of software and coding. And one of my friend actually used to work in a small startup in New York City. They do all this high frequency trading. Basically, very typical finance field. They write a lot of software and very sophisticated algorithms to do the kind of trading. And what he told me was that when writing this kind of software, a lot of time they just use C, C++ because it's faster, because for those high frequency trading, that time actually matters, right? So they want to use the most efficient and fastest way to write a code. He even told me that they need to physically put their machines and servers closer to the stock centers like New York City and Nasdaq. I don't know where that is, but it has to be in New York City. So they need to physically getting their offices and servers closer to those machines so that they can get a better latency, right? So the solution here to improve or guarantee or optimize a better latency is to use a good language and also get the servers closer, right? So that is a pattern, okay? That is a solution to a common problem. If you want to do that, just follow it. For that specific context, it's going to work very well. All right. Another example here, if you see this kind of a traffic road, okay? I don't know if you ever seen or understand this one, okay? So what happened here is that this is called I think it's called a there's a name J term. I think it's called J term. Anyway, I forgot the name. But what happened here is that this one only I think you can see that in New Jersey, okay, in the state of New Jersey. There they have a very historical road called Road One. It's one of the very main like important highways. And then, so in their highway, if you want to turn left, right? So here in California, most of the time you just stay in the left turn lane and wait, just turn. But then they don't have the left turn lane, that you have to go straight and then you go this turn and then you turn that way and then that's how you turn left. Okay, so that's just a design. The problem, I think the reason they do this is because I think because the road were very old, so they just have to, they don't have the space to extend it, so they just come up with this approach to solve that problem. And you have to see that they solve the problem perfectly. So next time you drive there, you can probably still see a lot of this kind of designs. Okay, very interesting. All right, so that's called a pattern to solve a common problem within a context. Okay, so here is the definition of a pattern. So each pattern describes a problem which occurs over and over again. So it's repeated, it's not just one time thing. And in our environment, and then describes the core solution to that problem in such a way that you can use this solution a million times over without ever doing the same way twice. Okay, so it really highlights a lot of things. You need to have a problem. The problem is not one time. And then we provide a solution so people can follow that solution repeatedly and always gonna get the results, same results. Okay. So I showed you so much. I just want you to understand the concept of pattern. So it's a very practical approach in software design field. We've seen this a lot. There is a very famous book called Design Patterns. So if you once again, if you took the course with me next time, we'll talk more about this one. But you can always get this book. So in this book, they talk about 23 different software design patterns. You can read it. It's not very hard to understand. How do you make your code, especially object-oriented programming code, more extensible, better design? Obviously, you're not going to become a master right away after reading the book, but if you follow things from the book, it helps you to become master much more faster because those are really good patterns they have summarized that are they being proven to work very well. All right. So anyway, so the rest I'll skip it. So just give you some ideas on the software design pattern. So like this pattern is called the observer pattern. So they talk about how you actually structure your classes, your code, so that if you want to do something like a notification, okay, something gonna change, the rest gotta notify. For example, you are building a stock like a market software, okay, all the stock prices changes, right? But a lot of clients are watching that price. How do you make sure the price changes are immediately reflected in all the different clients? There may be hundreds of thousands of clients watching the stock. How can you make that process, notification process, more efficiently? So this pattern actually tells you a perfect solution to solve it. And if you follow this way to structure your class, to make the calls, and then that's how you can make the software much more extensible. Okay, so this pattern is called observer. All right, so just one example. So they figure out a problem, they identify the problem, they give you the solution, and use this one and get the results. Okay, so that's just a quick overview about software design pattern. But coming back to the prompt pattern, same idea, right? So we want to write, we want to get a good result, want to get a good responses. A lot of the time you can just basically ask a question to do it, but now I also want to show you there are certain kind of patterns or templates that can make your answers getting received much more effective, right? Most of the things are coming from this paper. This is a paper I talked about earlier, and the main author is Dr. White, and then Dr. Schmidt also part of the paper. So this paper came in very early. I think it was around early 2023, very early. So they follow the same way idea of software patterns. They started define the prompt patterns. Every pattern define the name, the intent, the motivation behind it, and the structure as well give you the sample code and consequences. So, and then in this paper, the early paper, they summarize this many patterns. We'll pick up some of those to discuss. Some of this one maybe have a change. There are a lot of maybe new patterns you can use, but the idea remains the same. So we want to introduce this one not just to kind of learn all the specific pattern, but more importantly, you need to have some kind of mindset that as you use AI, you should always try to summarize the pattern, always be aware of some of the working existing patterns that you can integrate with your work. That's why for the next assignment, we do ask you guys to also come with your own pattern. Okay. So with that, let me actually start to introduce just a couple patterns today. We're not going to go too much. And then I'll start from the first one. Okay. So here is our first prompt pattern. We'll call it persona pattern. So here's the definition. And so if you want to use this pattern, so you should make the following fundamental contextual statements. You want to say act as a persona X to perform the task Y. So the X is a appropriate persona, just basically a role of someone, and then you perform a task just given to that specific persona. So as you can see from this one, what they're really asking you to do, instead of just asking a regular question to explain certain things, to do certain things, if you can add a persona in front of it, it normally will give you a much better results. Okay, so as you can see here, examples. As a nutritionist, I am going to tell you what I'm eating, and you will tell me about my eating choices. Okay, so let's actually just ask to send this one first without using the persona. Let's actually feel the differences, right? So I'm going to tell you what I'm eating, and you will tell me about my eating choices. Okay, I had a cake in as breakfast today. All right. The fun side, they start to talk about this one. You definitely start a day with a sweet happy note, give you a quick mood boost. It's kind of like giving yourself a surprise party. The nutrition side, they did mention that a little bit. A lot of sugar, quick energy. You might feel hungry getting soon because it doesn't keep you full for long. And the balance stuff. Okay, so they did give you a very good results, right? But then if you change it, I'm gonna send this one another time. I put a role, I put a persona as a nutritionist. Okay, so we want something more professional. All right. And then I would say the same thing. I had a cake as breakfast. All right. So as you can see, this time they don't talk too much about like give you a good mood or anything. They just dive into here are the pros and cons. And then even though they previously also mentioned that one, but you can see the tone, the way they present it is different. This is more formal, more professional, and they gave you healthier adjustments. Specific. These information are all mentioned in the previous one, but this one become just more professional. Okay. I think the diet is a pretty simple thing, but sometimes if you talk about something more like professional, okay, I think you will probably get some different results, right? So what else? Let's see other interesting example. Um, all right. It's all about eating choices. Let's just do something else. Okay, I would say, uh, uh, teach me how to make my lecture video more professional. Let me start a new one. Okay, so then they started um, talk about, break down into visuals, audio, content delivery, post-production polishing, visuals, lighting stuff, audios, content delivery, post-production. Pretty good, pretty good. But we'll say act as the number one YouTuber, Mr. Beast. Teach me how to make my lecture video more professional. Yeah, he actually explained that Mr. Beast isn't famous for just crazy stuff, but also keeping people hooked. All right. As you can see here, the first one just gave you very formal stuff. And here, they actually give you much more specific context. And I think if you read this one, I feel, some of those are maybe similar to Mr. Beast's style, right? So start big in the first 10 seconds. That's probably, yeah, that's exactly what he did. So instead of saying today we're going to learn about machine learning, and in the next 5 minutes, you understand how Netflix predict what movie you will watch next. It's all about machine learning. See, that's the kind of thing you're getting, right? Because you actually specify the persona, the role, who is going to talk about this one with his or hers professional experience, and you're going to get different things. And also they use the challenger frame. Yeah, this is also something I think also pretty common. I'm going to try to explain quantum computing under 3 minutes without confusing you. Right? Very, very, definitely, really good script. I have to say. Okay, I'm not good at writing and scripting, but looking at this one, this is probably 10 times better than what I can come with. Okay, and they cut every 5-10 seconds on screen text and graphics. As you can see, the whole thing you are getting totally changed. Okay, so as you can see, everyone we're just using the same ChatGPT. Okay, just by using the different prompts, you are getting things quite differently, and if you do it right, you're getting the good information much more effectively. Okay, so that's the goal we're here trying to learn the patterns. Very simple thing, but this one is nothing hard. All you need to do is to see, oh, there is something called persona pattern. Actually, I can add a persona in front of it, and that's all you need to do. Much, much simpler than the software design pattern. Software design pattern pretty hard. Every single pattern, it took us one lecture to explain and show you examples. This one, all we need to do is just show some examples like this, right? Um, you can also say this is something like for fun as a computer that has been the victim of cyber attacks. Respond to whatever I type in, the output that the Linux terminal will produce. Ask me the first command. Let's try this. Okay, so this is a more like kind of experiments. Instead of just getting answer, you can let AI to be, just act as a computer. Okay, and then to simulate certain things. All right. And then, so yeah, they just simulate some kind of a um, terminal. Okay. And if I type a command, we'll see how it responds. For example, in the Linux command, we will do, a copy SSH dot key file to the home, like, users, Tom, like, like, a homework folder. Let's see what they're gonna do. So since this one has been attacked, I don't know what they can produce. Oh, okay, nothing. But then this one is right? But it's not gonna show anything. But this one has been attacked. Okay. How about I do CD? I'll go to that folder and then I do a list. Is that gonna show us? All right, show some this one. But anyway, so as you can see, this one, whether it's been attacked or not, okay, I think this one is not really well simulated. But if you tell the ChatGPT to become a computer with the Linux, right, it will start respond you like this, because you specify the persona. So right now, the ChatGPT model is a computer with a Linux terminal. Okay, you interact with that, then you get a response. I think we should be able to, just give you all the to simulate. I think let me try. Okay, so being the victim of cyber attack, which triggers the computer to do totally wrong things for every single command given. Okay, let's try this one more time. I'll just do ls, which is to list all the files. All right. Yeah, but it looks like looks like this is better, right? So now you do else. Suppose that you're just seeing all the list of files, but now you actually see all this random stuff. That's obviously not what the ls list command should do. Okay, but yeah, because that's how you define the persona. Okay, so that is the very first pattern. Okay, very simple, very straightforward. Okay, so what I will do right now, guys, is because this is very simple. I want every one of you to create and try this immediately. Okay, so I'm sending a Google form right here. Um, I want you to right now write your own persona pattern example. Try it. And if you think that's a good one, I want you to submit it in the Google form. Okay, so I'll give you like 5 minutes. Everyone should do this. Okay, submit to me the um, the pattern. You test it. Okay, just apply in the persona pattern. Find that link in the Google chat. Sorry, in the Zoom chat. Okay, I'll give you 5 minutes. Try it. All right, very good. Some of you started sending this. Everyone need to do this, okay? Mm, Submit this one as soon as you can. All right. The job interviewer interview me for junior software engineering position. Okay, pretty good ones. All right. So these are some of the things that you can just use right away. As a personal career coach and experienced recruiter, I'll provide you with a job description resume, and you will tailor the resume to the career opportunities. Okay, even more like a specific, more details. Okay, very good. Well, looks like you guys are really care about the careers. Okay, all right. As the professional chef, Gordon Rasmi, and make me the recipe given these ingredients. Very good. This is a professional one. Carlos, I don't know if you wrote this one, the AI wrote this one. This is I won't read it, but this is a pretty good one. Okay, it was the more details you can provide, the better. Okay, yeah, read the one I just sent. That's from Carlos. Pretty good. Yeah, reading the prompts you guys sent, I realized that yeah, you all have pretty similar common interests. Okay, the yeah, the ingredients, recipes are always a big thing. I'm a little surprised. I don't know. You guys all, a lot of you actually like cooking. All right. So many things about like recipes. All right. Pretty good. Yeah, one more minute. Yeah, this is also a pretty good one. This one from Daniel. All right. So yeah, we're gonna stop here. Okay. So please be submitting this one. Okay. And then so the patterns here are pretty straightforward. Okay, let me resume. And yeah, but one thing you can find, it's not I would say it's not just about the persona. It's also by giving even more specific context, like Mr. B. like the 1990 Japanese car racer, right? So if you can give those kind of more detailed stuff, it will only make your response even better, right? So I'll just write this down. Um, be even more specific about the persona will help. All right. Uh, here are just some more examples. I think those are coming from our students. And yeah, so anyway, so there's nothing really too special. Okay. But yeah, from now on, just remember the persona, especially something about professionals. I think you can get a more valuable answer. So the pa second pattern we're going to introduce called audience. This is actually very practical. I think everyone should use this one, especially when you try to use AI to learn it. It's going to be really good. Okay, so use this pattern. Your prompt should make the following statements. Explain X to me. Assume I am a persona Y. So this is the opposite of persona. So the persona is that you define a character persona and then you want the output to be coming from that specific persona. Where this one is that you define the audience and then you want to explain certain things to that specific audience. And obviously you want explanation to fit to that audience, right? So this one is really useful when you try to learn and explain certain things. So for example, explain what is RNN. If you just say this one, and then they start to talk about a very formal definition, the recurrent neural network is a type of neural network designed to handle sequential data where the order matters, and memory pass input, looping structures, application, they even give you formula stuff. Okay, so if I say explain what is RNN to a um, third grade boy, all right? And then you're going to totally see different results, right? Imagine RNA is a boy with a notebook. You're reading a story one word at a time. After each word, you write down a quick note about what you just read. And when you see the next word, you don't just look at the word, you also pick your notebook to remember what came before. That way you can guess what word might come next or understand the story better. Okay, they give example. The dog is very, and you don't know what's the next word. And you remember dog part from your notebook. So you read it, your brain said, dogs are often cute or funny. So you guess the next word should be cute. Okay. Why is it special? A normal computer only look at the word right in front of it, but the RNN looks at the word everything before it, just like using memory, the whole sequence. It's a perfect explanation. Now think about if you got a younger brother or sister, you want to explain certain things to them. You probably have done this. Okay, it's not easy. Okay, especially some of the you know simple concept. And explain to the younger kids is no easy. And this one, I think they just gave you the perfect answer. Okay, now you can even go to more specific. Explain to a certain group boy who really likes playing Roblox. Okay, and now we'll see the result should be different, right? So you're playing a obby game. At each point, checkpoint, your character doesn't just see the next jump. It also remembers the jump you already did. If you run across lava, climb ladders, and then see a new spring block, your brain says, "Oh, the game is getting trickier. I should be careful." That memory helps you to play better, not just guess from the one block in front of you, right? Perfect example. You use a parkour obby game to explain the steps. This is just perfect. All right. So see, that's the power of the audience pattern. Don't just say explain certain things, do certain things. Specify the audience, and then that will help you so much. Okay. Very simple. This is a very simple pattern, but I think it's one of the most powerful pattern I can ever seen. So explain large number to assume I'm a bird. Explain how the supply chain is for the U.S. grocery store works. Assume I am. Anyway, so this is easy. Okay, I'm not gonna read more examples, but use the link, submit your audience pattern. Okay, do it right now. Some good ones. Explain the A-star pathfinding algorithm. Assume I'm an elementary schooler. Okay, so that's obviously very challenging. This is actually interesting. I'm very curious what kind of result you're getting. Okay, explain the wrong planet Earth to me, but assume I'm a flat earther. Yeah, very interesting. Yeah, this should be very helpful. Explain how to configure Python EBS code. Assume I never had previous experience. This will be also very useful. The quantum computing or quantum physics. I think this is probably one of the most difficult concept you can ever learn or understand. This will also practical. Okay, uh, how the attack works. If I'm very familiar with Overwatch. A lot of these are pretty good. But anyway, so next time when you are trying to use ChatGPT to get answers, as I was preparing some of the RNN stuff, some of the examples you can see, I also use ChatGPT to get those. I keep switching different audiences to see the results. The fundamental line here is that when you're learning things, just always try to let it explain to like a beginner to the right level. And yeah, they can do a really good job on that. Right. It's also pretty interesting. All right, sound good, guys. I think you all get it. Okay, so these are what we call like a prompt patterns. So there are still some others. As the model is getting more and more powerful, I have to say that some of the patterns become less significant compared to before because in the early days the pattern really the key. But nowadays, even your prompt is not quite right. Some of you probably have this experience. They can still try to understand what you're trying to talk, and then they give a pretty decent result. But some example like Mr. Beat, the Japanese car racer, those things, if you don't give it, I don't think they will give you that type of responses, right? So learning these patterns too, very useful. Okay, so I'm only going to talk about two today. Okay, we'll leave the rest next time. But take a look at the assignments. Okay, the assignment is that we want you to summarize two patterns. Okay, to create your own. Okay, it's not something I introduce. Do your own. But I do need two patterns. One pattern is something that just like persona or audience pattern that is very generic. Okay, you can use for any kind of a content like X and Y, this type of things. I also want you to summarize a pattern that's more application based. So, for example, previously, I see some students just say, "Oh, I have this prompt that always can generate a random playlist for me, to give me like a movie recommendation, something like that." That's very specific to the certain things, one thing, right? So I wanted to do both because last time I didn't ask this one, a lot of you actually gave me application, which I also think very useful. But I do want you to think about a specific application, like the racing car stuff you guys are interested, and also a bit more generic, okay, a more abstract kind of pattern that can be applied to similar problems again and again. Okay, so this one you have 2 weeks to do. Okay, nothing urgent, and then you just submit it. As I mentioned, in 2 more weeks, we'll come back to do a printing to see what kind of pattern you can create. All right. So yeah, I'm gonna stop here today. Okay, so we'll come back on Thursday. Thursday we're still running this in Zoom, and I'll talk about the rest of the patterns.